Good morning. I will be presenting a basic introduction towards the topic of wireless sensor networks. This course is intended for providing a basic input to the undergraduate students so that they can pursue their studies, their research work in this upcoming research area. So welcome to the lecture. The contents of the lecture would be introduction, the basic components of the wireless sensor networks, the node components, the categorization, the structure. We will also describe what actually a sensor node is. We will also address the functional aspects of sensor nodes, what are the typical types of sensor nodes, how they communicate or the transmission between sensor nodes, and the design factors and challenges associated with this field. Further, we will focus on the limitations of wireless sensor networks, and lastly, we will discuss the application areas dealing with wireless sensor networks. Basically, wireless sensor networks, they consist of distributed or autonomous sensors that cooperatively monitor the physical environment and including the environmental conditions such as temperature, sound, pressure, motion or pollutants at different locations over a time or over a space. These networks are highly distributed. They can comprise of hundreds or even more than 100, say in the range of thousands of tiny lightweight sensor nodes that form a network and cooperatively monitor a domain or a region, and they also send or receive message packets over wireless links. As far as the components or the basic components of wireless sensor networks are considered, they are containing an assembly of localized sensors. They form an interconnecting network. The assembly of localized sensors, they form a network. They have or they focus or they create a central point for information clustering, and lastly a computation part is done at a central point or a server which handles the collected data from all the sensor nodes. A sensor network is a typically small network which comprises of sensor nodes which are battery powered. They are wireless devices and they process onboard processing. They have the capability to communicate with each other or with the central server also, and they have some sensing capabilities. As far as the device schematics are concerned, they have a storage point, they have a processor, they have a radio for working which has a RF range, and definitely they are self-powered or they can also be powered externally, but in the 90% of the cases they are self-powered. A sensor node, it comprises of a low power processor which has a limited processing capacity, a limited memory. As far as the radio is concerned, it has low power radio which has a very low data rate with a limited range. As far as sensors are concerned, they are scalar. They can measure temperature, light, pressure, motion, and they can be existed or they can be placed in form of cameras or in form of microphones. Broadly, a wireless sensor network, it can be categorized as a homogeneous network or a heterogeneous network. When we talk of homogeneous network, it is a network that has identical sensor nodes and they guarantee to perform a specific task. And it is nearly observed that the nodes nearly expire at the same time. Coming to the heterogeneous part, they are formed with more than one type of sensor node integrated to improve the scalability of wireless sensor network, and they offer higher bandwidths for some special or some advanced applications. We can further structure a model of a wireless sensor networks. They can be either categorized as unstructured or as structured. In unstructured model, the nodes are deployed densely. Their deployment is random. Most of the cases, few regions remain uncovered. They are left unattended, and it is obviously a difficult process to maintain. As far as the second model, the structured model is concerned, the sensor nodes are deployed in a pre-planned manner. Very few regions remain uncovered. They can be easily monitored. The network can be easily monitored, and obviously it is easy to maintain. As far as the detailed description of a sensor node is concerned, now currently with the advancements in the MEMS technology and in the ASIC domain, The cost or size of the ICs, it has decreased a lot in order of magnitude and by order of cost as well. So the sensing devices, which are referred to sensor nodes, are definitely the basic building blocks of wireless sensor networks. They contain onboard sensors, processors, memory, transceiver, a power source in the form of battery or in a form of solar cells, and they convert physical phenomena like heat, light, motion, pressure, vibration, sound into electrical signals. The functional aspects are an important part of sensor nodes. Since sensors or wireless sensor networks, they operate under harsh conditions or harsh environmental conditions, their performance can be judged on the following factors. That is, they should be generic, that in order to control various sensing activities for data scheduling or data transmission. They are supposed to be self-healing, that is, fault occurs in one of the sensor nodes, it should not impact or it should not affect the entire network. And lastly, they should pose efficient communication, that is, they should have minimum failures, they should have a backup in case of failures to avoid the sensed data, to avoid losing the sensed data, and they should also retain the sensed data in an effective manner. There are few more points or parameters that need to be addressed, like a network should have a flexible sensing range. They can be, that is, the range can be adjusted from a higher end to a lower end or vice versa. Definitely the data which is received or fetched, it should be accurate in terms of accuracy, or it should be highly precise. They should also extend some functionality besides sensing, and they must provide data forwarding in form of packets. They must be robust, or they must be susceptible to the changes in the environment or when they are placed in extreme hard conditions, and they should sufficiently operate for longer periods of time without any problems or without any faults. And since I had discussed before, the power part is a important or a crucial part, and they are self-powered, the power is limited, so it is not possible to replace the batteries frequently, so they must consume less power. When nodes are connected to form a wireless sensor networks, they can further be divided into 4 basic categories. The static sensor nodes, that is, when a wireless sensor network is deployed, the nodes, they do not come into motion. They are static, they remain there when they are deployed. Mobile sensor node, definitely the sensors, if they are attached to a moving object in the form of wireless sensor network, the nodes come into motion and they are rated as mobile sensor node. Global sensor node, the nodes that process data collected from the entire network, or when the size of the network is extremely large, the nodes are referred to as global sensor node. Coming on to the smaller part, when the nodes, they process the data collected from a small or a limited region or a particular region from a network, they can be termed as regional sensor node. In both the cases, either in case of global or in the case of regional, the nodes can either be static or they can be mobile. As far as the transmission between the sensor nodes is concerned, there are 3 ways or 3 points in which the transmission generally takes place. A single node can communicate with many other nodes. More than one sensor nodes can communicate with another set of more than one sensor nodes, that is many to many part. Or a group of few sensor nodes, they can communicate with a particular sensor node, that is many to one sensor nodes. And based on this communication, the data can be disseminated in the form of the propagation of data queries throughout the network, or the data can be gathered, that is, it can be collected, or it is a collection of sense data from individual sensor nodes to a central position, or to a sync node, or to a base station. Definitely the data rates for communication within the wireless sensor networks, they are provided by IEEE 802.15.14, which operate under the 2.4 GHz band for short range wireless communications. And the data collected by the sensor nodes, either they are stationary or they are mobile, can be forwarded to other sync nodes, possibly via hops. See, this is a figure which can explain how data is propagated in form of hops. The sync node is assigned, it captures the data from different individual sensor nodes and forwards it to a gateway, and further the gateway forwards it to the user via some network, say like internet or some other network. So this is a form of one to many or many to one communication which uses a sync node. As far as the design is concerned, these are the important design factors which have the important role in the development of wireless sensor networks. These are the design factors or challenges which can be addressed as a upcoming research area. They are fault tolerance, the scalability. When we talk of scalability, it means how the number of nodes can be increased. The production cost, how can a cost of a particular sensor node be reduced. How to control the topology, that is the arrangement of sensor nodes in a particular environment. What type of transmission media, RF or infrared, is being preferred or it is being used. Mobility, again, we can focus on the mobility models in the later lectures. The power consumption, this thing we have always also addressed that it should be low. Redundancy, that is the duplicacy of information, or when the same information it is repeated again and again within the network, it leads to a chaos or congestion. It should be minimized. And localization, that is the estimation of position of sensor nodes or within the network, is referred to as localization or self-localization. So these are the important aspects that are currently being worked into, or they are important areas for research. These are the few limitations of wireless sensor networks. The first one, definitely in terms of power. The second one says that the battery should be rechargeable. The energy consumption, that is in the form of sensing or data processing. For some sensors, sensing may also be energy extensive. The requirement of energy conserving protocols, or the requirement of protocols that suits a particular bandwidth, and the spatial reuse of the bandwidth. So more or less, WSNs are limited in terms of power, or you can say in terms of bandwidth. So these two domains, they pose serious limitations. Number one is power and the other one is the bandwidth. As far as the application areas are concerned, WSNs, they have a plethora of application areas. Broadly, they can be divided as, they can be used to monitor objects, they can be used to monitor an area, or they can be used to monitor both area as well as object. Since the applications are vast, they can be used in healthcare, they can be used for office or smart homes, they are used in robotics, for other safety applications, for industrial applications, for agriculture, for seismic monitoring. There are a few of the advanced applications like biomedical or medical. They can be, sensors can be used to measure the heart rate, they can be used to measure the level of glucose in the body, they can be used for retinal transplant, they can also be used for other recordings which are necessary for a hospital. For habitats, the ZebraNet project, it is a project which is used to monitor the movement of zebras in Kenya. The zebras are collar mounted with sensors and you get the position of zebra in a given area. As far as disaster management, you can deploy sensors to detect the landslides or to detect some another natural calamities well in advance before the disaster occurs. For environmental monitoring, you can control or you can measure the air pollution, the level of air pollution. You can also detect the fires or firebugs in forests. We can also use WSNs for greenhouse monitoring in agriculture and for weather forecasting as well. Smart homes and smart offices, they need a sensor network in order to better the shape of building or in order to adjust the lighting levels, in order to adjust the heating levels. And the Pentagon building has extensively used wireless sensor networks towards its design and construction. Sensors can also be deployed into the form of wearable monitoring systems, or they can be implanted into the jackets for different purposes, to measure the ECG or to even measure the respiratory activity of a person. As far as the defense sector is concerned, we can deploy a sensor network to monitor the movement of forces. We can deploy WSNs in hostile environments to, say for example, you can take the temperature, or you can measure the temperature of a volcano or inside a volcano using these networks, where the manual measurement of this high temperature is nearly impossible. As far as the structural monitoring, you can monitor the health of civil structures like bridges or dams, and you can also use them in smart cities for managing the traffic or for routing the traffic or for monitoring the flow of traffic. You can handle accidents, you can handle thefts, and overall you can make these applications essential for day-to-day life. So WSNs, they play an important role in the day-to-day technology, and they are important aspects. So this lecture, it basically provides